So welcome to the EPOS Data Portal training arranged by University of Bergen together with EPOS ERIC with participation of GeoInquire and Skills for EUSC projects who are contributing on different aspects of the open science and making data available and shared. The agenda for the training today is as follows. I will provide a short introduction of the EPOS ecosystem at the beginning. Then we'll go for a live demonstration of the EPOS Data Portal by following a scientific user story that will be given by a colleague of mine, by Harald. And then from 10:30 to 11, you will have time for your own hands-on training by following a scientific use case in a specific form. And also we will collect feedback from you about the training itself and the EPOS Data Portal. What is your experience? At the end, we will provide a short walkthrough through the individual task from the hands-on training, so you can kind of get confirmation whether or figure out why something didn't work as expected, or just confirmation it worked and that you did well. And then the last 50 minutes at the end, we will have time for discussion. It's generous time, so you can also use the Q&As during the presentation now. You can paste the colleagues of mine can try to answer those, or I can also assist you later. But we'll focus answering all the questions to the last part of the discussion. The presentation will start with introducing the open science. You are pretty much familiar with that, I believe, especially related to open access papers and journals for publishing the results. But it's not only about that. The open science is introducing a new way how to share the data and all the work actually the scientists are doing. So it focusing on open data, open source, open software, also open methodology. So describing whatever you are doing in an open way, so anyone can actually reuse that. Similarly, the open educational resources, so make the materials you are preparing also reusable by others. So open science represents a new approach to the scientific process based on a cooperative work and new ways of diffusing knowledge by using digital technologies and new collaborative tools. That's a statement from the European Commission document. And the primary goal is that to make whatever is generated by public funded sources to make available again for the public in a digital format with no or minimal restriction. So whatever you produce, thanks to public funding, it should be also made available. And that's what also EPOS is trying to do, making all the data which are already being shared, integrate and provide an easier access to those assets through a common platform. The open science brings its own benefits and barriers. So the benefits, you will always have the data much easier to access in a good time. So making actually the most of the data which are available. Verifiability, it means that all the data are already approved by someone or those who generated those data. Reproducibility, so you can reuse the data and reproduce the results which were achieved by other scientists. And of course, in that way, you will use efficiently the research resources, so you will not need to reinvent things, because if the data is already there, you can just reuse. And of course, if the methodologies are open as well, then you can just use it for your advantage, for your research. Of course, there are difficulties also how to get there, because it requires an additional work, let's say an overhead, which is coming on top of what you are normally doing. because you need to understand the different standards, different vocabularies. There's a lot of fragmentation which needs to be removed. It might require a lot of communication between you as a scientist and the IT experts to understand how actually to get the data integrated and follow the standards in the best possible way. Making it also creates an overhead to make the data open and fair. I will explain what the fair means in the next slide. And of course, there are also might be perceived issues on the intellectual property rights. Who is actually the owner? So that's also sorted usually by license. So everyone is assigning license to his own work, and then also, of course, having the digital identifier or DOI, so then anyone else can use and cite properly the work which has been published. Of course, the legal and ethical issues, how to use, by whom to use the work, those are also difficulties, but it's not possible, or it's not impossible to overcome those. As I mentioned, the FAIR principles, they are well known and discussed at many different levels, especially related to data management. The FAIR stands for findable, accessible, interoperable, reusable, and the last R, which is now in the parenthesis, is making that everything also for machine readable. So it means that not only humans can comply with these principles, but also machines. So it means you need to have correct metadata models which the machines can understand and interpret and connect to other assets in the best possible way. In practice, the open science, it means that it's a lot of communication, consultation, and co-creation, and that's what it's integral for EPOS. So we are not just creating catalogs, but we are adopting a service-driven approach to openly share the data and products, and it's especially driven as bottom-up through the communities. So we have 10 thematic communities within EPOS, and that we are actually building on top of those communities and their services. It requires collaboration among scientific staff, the IT and the governance components are key, how to actually glue everything together. And of course, engagement of the communities is the crucial thing, especially for harmonizing the data and processing them and making them standardized. So, of course, making with the only ultimate goal to make everything ready and usable by the scientists. So it's work done by scientists for scientists, and everything it's open publicly and free. So that's the advantage you can use of. EPOS, the European Plate Observing System, it's moving toward global science. So trying to merge everything into one place and make it available from one place. And the goal is to have the infrastructure long term. So building it, it's not just a project, it's an effort which started already back in, let's say, 90s, the idea how to make things happen. And it's evolving, and since 2016, we start developing the system, and also on the governance level, it's getting more and more coordinated. And now there is an EPOS ERIC, and ERIC stands for European Research Infrastructure Consortium, which has been established in 2018, as you see here on this side. Now it's a legal body residing in Rome and governing the further EPOS developments. In 2023, the EPOS Data Portal as a main product was launched into operational during the EGU in Vienna. And since then, we're trying to convince scientists that to use it and training them and explaining how the EPOS works, how the portal works, and how also the data flow works, and how to get the data into the system, also from new communities and new countries. As I said, EPOS ERIC has been established in 2018 as a legal entity, and it's recognized in all EU member states. And the principal task of an ERIC is to establish and operate a research infrastructure. In the map, you see in the dark green the members of EPOS ERIC. The light green are the observers, currently Germany, and plus the red countries which are included in the EPOS integration plan, but not yet integrated fully. I have some additional numbers here of what currently we do have in place. We have about 87 data and service providers connected in the system, but there are actually even more data providers behind. Let's say these are those we can easily count. We provide access to more than 800 terabytes of data, which are distributed around Europe. So our system is not downloading anything to a central local place, but we are just making things connected at the European landscape, at least for now. Currently, we have 264 data services, which you will then explore partially yourself or anytime later using the EPOS Data Portal. So far, we had more than 16,000 unique visitors in the EPOS Data Portal since the operational launch in April last year. Just briefly mention the EPOS research infrastructure and the architecture behind how it actually works. Just give me the laser pointer. So you see on the left-hand side are the thematic core service, which are actually building the whole EPOS community. So those are the data providers and service providers which are connecting to the central system and providing the data products, software and services through an interoperability layer. Technically, it works that currently EPOS is supporting the data provision through services. So those services needs to be mapped into metadata structure, which is called EPOS DCAT AP model. And then we ingest the information about the services into our central catalog. And from then on, you can search through the catalog and then connect to individual services back at the thematic core services level. So that's what we call the central system, which provides the catalog of the services, but also having other components for connecting things together. Also the graphical user interface of the EPOS Data Portal, the APIs, which are driving the whole system in the background. On the right-hand side, you see distributed core services, as we call them also ICSD. Those are potential new components which will connect to the central system. It can be HPC, it means high performing computations or high throughput computations, additional visualizations or extra storage or other IT resources. So those are planned and now being developed as pilots. I will show you a few slides about that, the pilot implementations we have now running. But currently what you can get is basically the access to the thematic core services. So you can find the data, download it, or even pre-visualize on the EPOS Data Portal in a simple way. The main users, considered users of the EPOS system, are scientists, but also governments, private sector, and society. Anyone basically who is interested on getting high quality data, which are approved and served through the communities. Here I have introduction of the 10 current communities we are working with and from which we are integrating data into EPOS. So the first is seismology, waveform services, seismological products, earthquake hazard and risk products, for example, maps. And the next community is near-fall observatories, which are providing access to seismological, geochemical, and geophysical data around the large faults, and known faults or seismogenic faults in Europe. Third community is providing access to GNSS data and products, again at the European coverage. Volcano observations. This is a multidisciplinary observations around the volcanoes, Iceland, Italy, also France, and Greece. So we have several areas where we have observations of volcanoes. Then satellite data. Currently, we have mostly INSAR data and their products, which you can find. And next community is geomagnetic observations. Those are mostly global observations of the geomagnetic field, but also individual survey data based on magnetotelluric observations. Community anthropogenic hazards is observing or collecting observations around mines or exploited areas, like wherever humans are extracting the energy or resources from the earth, and monitoring those areas. So be around the old mines or exploitation area, for example, of geothermal energy. The next community is geological information modeling, providing access to boreholes around Europe, the geological maps, also 3D 4D models and mineral resources. Multiscale laboratories are dealing with observation in labs. Those could be analog modeling of geological processes, paramagnetic and magnetic data, and rock and melt physical properties, basically measuring on samples. The last but not least is a TCS tsunami community, which is the newest one in the EPOS community, and providing tsunami data, observations, and also hazard and risk products. The technical architecture, how everything works. So today you will see the EPOS Data Portal, which is the GUI, the graphical user interface on top of the whole system. But that actually what you will see is just a tip of an iceberg, because the actual work and data lies beneath. So once you go to the portal, you connect to our central catalog, which is actually the ICSC, the centralized services. And from there, we are redirecting you to individual services, which are at the bottom, to individual communities. So if you select a service, for example, you want to get a geological map, we redirect you to a geological information modeling community server and getting the data right from there on the fly as you requested. So it has an advantage and also disadvantage. The advantage is that you are getting the data up to date at any given time, because you are always asking to the source of the data. The disadvantage is that since it's a federated system, it means that everything needs to be connected at any given time, or at least when you are trying to access the data. So if something goes down, we might have trouble to get the data for you. But we have also a monitoring system in place, which is observing frequently every 15 minutes, querying the individual services. So we have good understanding what is working and what not, and if not, there are notifications and so on. So the whole system is being monitored, and we know what is happening at any given time. The EPOS Data Portal is built in having the FAIR principles in mind. So we're trying to apply the FAIR principles everywhere where possible and integrate the practices. And that's possible thanks to co-development approach and harmonization actions across the communities and developers and data providers. So this is a screenshot of the EPOS Data Portal. with some services in my favorites. And this is the current status. You will be able to come to that in a minute, but please don't go there yet, because we want to give the live demonstration, and afterwards you will have time to do your own hands-on practice of the portal itself. Just 2 more slides about the further developments we are working on. So now currently the EPOS Data Portal, go back, provides data discovery, pre-visualization and download. But we think further than that. We want to provide the scientists truly processing environment, so they can not only find the data but also do the processing online from any place. So we are integrating now Jupyter Lab environment, so you can connect it, or we will connect it to the main portal. So once you find the data, you can deploy them on a specific virtual environment and then do process the data using, for example, Jupyter notebooks, and make either processing or visualization there. In addition, we are connecting an additional Enlightened Web, which is a visualization tool allowing different views and viewing the data in linked views. So here you see 4 different maps of 4 different assets, but you can also show the plot, let's say the data in 2 different plots of the same data, just different views. And those are kept linked. So if you, as you see in this right-hand plot, the black rectangle, the data selection out of the big cloud of data, it's also then linked and highlighting the points in the left-hand view. So just to explain what we are working on, we have the pilot implementation in place, and we expect that to have it in production by June or September this year. So that's all from my side. I will now give floor to Harald to provide the live demonstration of the EPOS Data Portal.
Hi, I'm Harald. Thank you for the introduction, Jan. I will introduce a brief demonstration now for the EPOS Data Portal. It's great to see many people here. And can you see my screen now? Can you confirm on that?
Yes, I can.
Very good. So the first thing you're prompted with is this pop-up. And here, if you want, you can have email updates for future updates on the EPOS Data Portal. You can also start a guided tour, which goes through the elements I'm going through now. So let's see, I can press now, continue to the portal, and it's saved in a cache. So on the left-hand side now, we have a pane called data. You see a number here, it's 264. That's the amount of services available. So if you press this one, you can see the symbols here. Those are the thematic core services. These are the communities that provide data, which are visible now in this GUI. So then you have the data pane here, and you have the free text search here. And you can refine the search here with spatial or by 2 different methods, like coordinates or by country. And then you have a temporal range here you can set for your data. You can set the service providers, and you can also set data visualization, the 3 different ways of displaying the results. So now we are going through the other ones. You also have a location search here for specific places. You can zoom in or out here. And you have a layer and legend tool here. You can control all your selected services and the background layer. Then you have table view for the services that are displayed in that. And you have graph view for certain elements as well. Also in the menu, we have video guides where you have these as what Jan just showed is mainly showed here in the intro. But if you want to go further, you can go on data search or configuration and visualization of services to get an introduction there as well. Then we have the guided tour, which are basically going through what I'm going through now, step by step, and showing how to configure things and how to modify and what the different things represent. how to make bounding boxes and configure things further. Okay, so now I will do a text search on, let's say, geological map. Sorry. And then I will select the service here. You can put it to favorites directly, or you can click on it here. If you put it on favorites, then you can access your favorite here as a workspace. Now you can see the different layers are loading here for Europe. If I'm searching here for a place, it will zoom in and suggest a place for you. And then if we zoom out a little bit, it will reinitiate. Takes a second. In the background here, you can see Vesuvius, and then you can see Campifigure here. The two different volcanoes are the largest, most prominent volcanoes in the Naples region. So now that it's loading here, you can press on the map. So I could try to refine it. You can also refine the search, then only the area you have chosen will load. There we go. So this layer here is rhyolite, which is a extrusive volcanic rock, and its origin or its age is from Pleistocene. And let's see for Vesuvio. So also rhyolite here from the same age. And you can also modify the layer to be more transparent if you wish to display it like that. And I can customize here, and then you can see through like so. And let's say if we want more layers on, we can do that. Now I remove the free text search, and you can see all of these panes are now accessible. So I want to have a look at INSAR data. So line of sight displacement time series is one of them. And you can specify a data provider and the amount of tiles. And then we can see a different picture here. So these colors you will investigate later, but they represent the vertical displacement. And if you see here on the pop-up, it says the name, or in the name, it says the period. So there's a 6-year period. This is on average calculated from. So contrary to mainly, I don't know, a belief is that Vesuvio is subsiding now, and Campifigure is quite active, at least in this period of time. And the last eruption here was in 1945, and this one is actually like 500 years ago, but it is much more active now. So if we want to further investigate this, we can search for example, modern earthquakes, and then we have to go to seismology. And if I choose this one here, it's default set to 5. So 5 is quite strong for an earthquake in a volcanic area. So if I set this to 3, you'll see a pattern here. So it might be difficult to see here. Then you can modify the display of the service here. So you can have the marker icon as non-transparent, and you can choose the opacity, and you can set the color also so it's contrasting to the other ones. So recall that these earthquakes are from the last 25 or 6 years. Then you can further modify those. Let's say if I want to have the entirety of last year, I can do so here. And then the minimum magnitude here is set to 3 to have the strongest earthquakes visible. So if you recall or are familiar with the area, you can see that all magnitude 3 or higher earthquakes are in this period in this area. You can also see this in table view. So by default, it's set to 10, but you can set it to more. Right now, coincidentally, the amount of earthquakes over 3 are 10. You can also modify, or you can download these in CSV format if you prefer that here. And you can also download the data in this period as different formats here. And then it will prompt you with the XML, the Quake ML or XML, then JSON and the text as well. So then you have multiple format depending on the provider where you can download it. Okay, so if we go through, if I modify this one, we can also have a look at GNSS stations. So then I go first to GNSS stations with products, and then you can see the pop-ups here. If it's too difficult or too much things going on, you can always turn on or off these layers. You can also change the background layer. Sometimes I prefer to have dark gray, so you have the best color representation or contrast. Okay, so within this one, you can see a 4-letter code. This one is important. So if I want to find the GNSS station closest to Config, it's this one or this. Then I can copy this, and then I'll go to some of them that has graph view. Like, for example, this one, daily position time series from INGV. The trick here is you have to go on the advanced search filter, and then you can paste your 4-letter code. And by doing so, you have this set to graph view. And within here, you can have the east, north, or up component. You can also specify this as X, Y, Z if you prefer that. Instead, here you can save this plot as a PNG, like a snapshot. And you can zoom and hover around here if you wish that as well. So I can zoom into a specific period, and you can go through here. And if you want to reset this, you press the home. So then I briefly introduce the graphical user interface. Like you would go through different cases now. So then it'd be useful for you to know how to reset things between the different cases. So you can press the clear all favorites, and then you can remove the spatial. And if you have something here, you can also remove that as well. So now I'll briefly go through some tsunami services and some faults as well. So like I showed for now, I used the free text search, but you can also browse through the catalog here from different community. And if I choose 3 of these services, one is submarine landslides for the Mediterranean Ocean and scars here. And then for this case, paleo tsunamis. So given a few seconds, here we go. So the scars here are the areas that has been mapped where these landslides used to be before an earthquake or an event that triggered the slide of them. So if we go to Sicily, close to Etna, you can see if I press this point marker, you will get some information from a research paper giving 3 strong recorded events in old times, since this is paleo tsunamis. And then, for example, if I go to this one, it will give the same age as one of the tsunamis. So at least when you have for example, the scar here, and you have the submarine landslide and you have the paleo tsunami, at least the interpretation is up to you. But at least then you have some indication of what process has been going on. So if I briefly go to Stromboli, which is quite frequently active, there are 3 tsunamis events. But on this side, it seems like the scars and the submarine landslides is on the other side. So these probably are from another event. Yes. And then if I zoom out a little bit more, you can see some submarine landslides that are the size of both Sicily and Corsica together. So quite massive forces making these. Okay, so if I want to search for false, let's see how they superpose and correspond. Okay, let's see under seismology. So there are a number of these. Some of them are called database of seismogenic faults. And if I press this one, it's a collection of the crustal and subduction faults. If the colors are too similar to the other things, you can always go into the layer and legend tool and you can modify those. So here you can see what the different lines represent and the depth of the subduction zones. And you can at least modify the opacity of this one. And if you want to change another color for these ones, you can do so as well. So those pop a little bit more in contrast. But yeah, here you can see the distribution of the faults, and you can see the tsunami events, and you can also have old earthquakes or modern earthquakes, and see if you can find some relation between these at least. So yeah, that's my basic introduction to the EPOS Data Portal, and you will soon go through your use case. And if you have any questions, just ask us in the chat. And good luck.
Thank you, Harald, for giving the live demonstration of the portal. Now we are moving to the hands-on session. So we will give you a link to the chat, which is linked to the Google form. It will guide you through the user story and with the tasks to complete. Plus, we are collecting your feedback, your user experience on that portal and interacting with the portal. So please answer as many questions as possible, because it's very important for us to understand who are actually the users. Today it's a bit challenging because it's the first time we have so many participants. We received almost 400 registration. Currently we are 180 persons in this webinar, and we will be asking you to interact with the portal live, all the persons at the same time. So it is kind of a stress test also for the portal itself, whether that number of users can use it without problems. You might encounter maybe at some time when it's slow, but if you observe something that the system is not responding at all, you can also let us know, so we can take note of that. That will be also important feedback for us. So with that, I will now paste a link to the forum to chat, so you will be able to go through the individual tasks. The survey is fully anonymous. Only at the very end you have option if you want to provide an email, and then in that case your answers will be associated with your email, and also you can sign for or tick which information you would like to receive, which updates you would like to receive from EPOS in the future. Okay, so I'll just copy the link and I'll paste it to the chat. Hopefully everyone can reach it. So I just pasted there. So please go to that Google form. Then also open the EPOS Data Portal in another window. We'll also copy a link to that portal as a next. So you need to open basically two different windows, one with the tasks, second with the EPOS Data Portal, and then try to execute the task as we are asking. So you will have approximately 30 minutes to complete both the tasks. They are relatively simple, pretty similar to what Harald was demonstrating. So I expect you should spend about, let's say, 20 minutes on those tasks, plus 10 minutes on providing the general feedback in the form, and then we will reconvene back at 11, and I will guide you through the individual tasks. So now I will just mute myself and turn the camera off and pause recording of the video, and then we'll reconvene 11. So enjoy browsing the portal. If you have any problems, you can use the Q&As here or the chat. So see you in a bit. So welcome back. I see that we had several problems, or many people have problem with accessing different assets. It might be because the whole system is overloaded. I was struggling myself to get some of the data sets. But please, if you can, you can continue with with providing the feedback. I'm not sure if I will be able to execute the whole walkthrough smoothly because I'm still struggling to load the geological map. I will try to do it now again. Otherwise, I will be forced. Okay, now the geological map works for me at least. So you can also try to go back because now it might be less people doing the first task. So you might be able to complete the one. So you can go back and if you haven't submitted the form yet. Okay, so I will start sharing my screen and explain the individual steps. Okay. Screen here. So as you see now, I'll just close the individual fields I don't need. So you see the data portal. I will switch to the form. So I just navigate to the form where it starts describing the scientific user story. So you will be guided to Italy and explore various data sets. So if I go through the task number 1, which is focused on geological map, it's asking to search for geological map and then so geolocate to Italy and look on Sicily, the Etna volcano. Then we have the first question, what type of rock is Mount Etna mostly made of? So I will go back to the portal. I can remove the spatial filter, but I will go to the geolocation filter here. I will type Italy in here, and then it's immediately applied. The whole Italy is selected now, and now the layer is loaded in. Since I had the geological map already in my favorites, now it's supposed to load, but there might be still. Okay, now it's loading actually. Okay, so if I zoom in, then I can interact with the WMS layer with the geological map. I can click on that, and hopefully I will get the information back, because once you click on the map, it again makes a request to the actual data server and fetch the information from there. Yes, I got it. So I got lithology andesite. That's what I will be asking for. So the first answer to the first question was andesite, and then I can continue further on. There was a hint or screenshot for each task to indicate what you should see. So that's what we managed, and I managed to complete. So going to the next. Next task is focused on satellite observations. Then I should navigate to the satellite icon, and then look for line of sight, LOS, displacement time series, and add it to the favorites. And then understand the map content by navigating to the layer legend control. So I will go to the satellite data community here. If I click on that, and then I see the LOS displacement time series. I click on the star. Now it's being added to my favorites. Okay, it's also loaded in, so that's great. So now we see around Etna volcano different colors. To understand what the colors means, I need to open the legend, and then I see the color scale. Actually, I see many different color scales because there are multiple images shown or loaded at once. If I go to the service itself, I can see that I got 20 results back, which I can see also in the table view here. So I got 20 different images which are now shown on top of each other, and that's why we have so many legends. To be able to understand, but still all the legends are actually the same. The red color means that the ground is moving away from the satellite because the observation is made along the line of the site. So either it's moving away from the satellite or towards the satellite. So the red is away, the purple it's towards the satellite. If I switch back to the question, the question was, can you identify what does the red color mean in the map? And then we got that that's actually subsiding area. That's the red area which is moving away from the satellite. So it's subsiding. Not necessarily vertical sense, but definitely subsiding. So that was the second task. We are moving to the third task, volcano observations. Here I'm asked to navigate to service providing information about earthquakes around Etna. So I can go there. I have this service in my favorites. Yes, so I go to volcano observations, and then I see the Mount Etna earthquake parameters 2000 to 2019. So this is a service providing earthquakes within this time period. By default, I mean, each service comes with some default values. Default values are here limiting. So it's the maximum is 1.5, 1.7. So I'll just delete those to get more earthquakes. Also, I will remove the minimum depth. So now I deleted the default values. The task was to delete them and also adjust the temporal filter. So I can adjust it by opening this overriding option. Then I need to put 2000 here. I can put approximately 01, but I can keep the 22nd of January. And then here I would put 2020. Here is a bit tricky because you need to also confirm the date in the calendar below by clicking the apply. Otherwise, it will reset to the default value. So that's a small drawback here. Once I set this, I can check what other parameters I should configure. I should have north 39, south 36. So I can override also the spatial coordinates. 39, then 36, and west east it should be 14 and 16. So I can write 14 and 16. So this the values for the coordinates, and then I have the minimum MD magnitude and minimum ML magnitude set to 3. A minimum MD should be set to 3, and minimum ML as well as to 3. So once I did this change, I need to click apply, and now what's happening that a new request is made to the service, and new data is loaded in. So now you see we have many more earthquakes. To see how many, we have 135 earthquakes right now in this area. The spatial filter or spatial coordinates you can also define or override by the spatial filter here. If I would tick the coordinates and then draw a bounding box around, that's even easier to get the coordinates I'm interested in. But this way you can specify explicitly the values you want to get data from. Okay, so that was the task, and then I have questions related to this. The first question is, what is the largest earthquake magnitude you can identify in table view? So now I need to, I need to switch to the table view. I forgot about the third point in the task about downloading the data, but I will explain it right now while doing this, looking for the largest magnitude event. So I can put more earthquakes to more rows to display, but I'm fine also with 5, because if I click on the magnitude column, it always gives me the largest on top. I can click on either of them, but if I do so, I still see that the largest magnitude is 4.8 earthquake. So the correct answer is 4.8. I can go back to the form, tick the value. Going back to the third task within this exercise, it was to download the data, the earthquake data. So I can do it 2 ways. I can either download it, export the data in a CSV. If I click this icon, it automatically is downloaded in CSV format. It just export whatever is in this table. The second option is to get the data in other formats. So if you click the download button within the service configuration or under the service configuration, you have the dialog where you can choose which format you want to download. The task was to get the catalog in JSON format, so I will need to click this download, and again now the catalog in JSON format is downloaded for me. So I managed to do that, so I can tick both checkboxes and continue further. Okay, I managed to complete. Moving to the next task. The next and last task is focusing on GNSS observations, Global Navigation Satellite System. First point is to identify the GNSS stations with products. I can use the free text search. Okay, I will add the earthquakes to my favorites. Keep it for later. Then I look here for stations. And then I need to choose the GNSS data and products, and then I see the GNSS stations with products. I add it to my favorites. And now our server is connecting to the data provider and plotting the GNSS stations on the map. Now some stations are clustered. If I zoom in, they will split and they will decluster, but you can also enable that option for the in the customization of the layer. There's a cluster option. I can disable that, and then I would see all the stations at once. Okay, so I managed to plot the GNSS stations. Then the second point is to zoom to the summit of the Mount Etna and find the closest GNSS marker and note the 4-letter code of that marker. So it might be a bit difficult to see which where is the summit actually. So I can probably disable the LOS and maybe also the geological map. So the summit of the Mount Etna is here. So the closest station, it's probably this one, ESLN. So I can see it either from here or in the JSON station ID here, or I can also identify it on the table. So this is the station marker. I copy it to my clipboard to be used for another service. Because then the third point here is to search for daily position time series from INGV. So I can do that. I will clear the, I will just search for daily. And it's asking to search for daily positions time series from INGV. So I will add this service to my favorites. And as you see, the default station is SOPH, which I want to override because I'm interested in data from the ESLM station. Again, I need to click apply to get the data from that station. And as you see, this service is plotting data in graph view as well. So if I click the graph, it opens the graph, and then you can add individual components. I'm now interested in the vertical one. So now I see the time series since 2006 until mid 2022, I guess. Let's have a look. What is the task here? Yeah, so the question 4.1 is based on the up component in graph, what is the trend movement from 2016 to 2020? So here I will need to check 2016 to 2020. I can zoom to this area, and actually I see that it's moving upwards. So the right answer would be that the station is rising up. Question 4.2 is, does the movement of the selected GNSS stations between 2016 and 2020 correlate with satellite LOS displacement time series? So we see the image here. If I turn on again now the LOS data in the map view here. So here is our GNSS station. I will enable the LOS time series. I can disable the earthquakes for a while. So if I zoom in, so the station is located just on the edge where it's kind of this area is subsiding. This is uprising, at least based on that INSAR data, while the station itself is located on the edge, which is slightly orange, but also close to the green. So it's difficult to say. So either option, either no or difficult to say. I would say difficult to say because from the observations we see that the station is rising up, but at the same time from the INSAR data we see that it's close to an area which is subsiding. So it might be actually the opposite behavior, but it's difficult to say based on that. So that's why I chose the difficult to say here. Okay, and then I think I can go to the next, and here were questions for you to respond on your user experience with interacting with the portal. So I will stop sharing my screen here. I hope you managed to follow or complete. Let me see how many answers we received so far. Okay, we got 43 responses from you. So thank you very much for that. We can also go towards the end through the answers, but if you are still submitting or working on the task, please feel free to do so. So now we finished the main part, the introduction, hands-on training. Now we have time for discussion and questions. I prepared a short poll just to understand what problems you had with the data sets, because many people were complaining through the QANs that the geological map was not showing, or maybe also other. So I would like to ask you which data sets you were struggling to load in. So please just vote in there. There are multiple options. You can choose many of them. I would like to know what the problem was. So most cases looks like it's actually the geological map. Also some issues with satellite data, earthquakes, but those are pretty much equal. So it seems that the system was overloaded when everyone try to access the same service at the same time. I'm actually happy that I managed to to do this work through live. So it means that the system recovered, but still there is probably a limit. So we need to check with the hosting organization when the limit was reached, so we actually see the problem. Okay, so we get 71 votes in this short question. I will keep it open still for maybe 2 more minutes. I would like to open the floor for general questions. So if you want to, you can even pose the question loudly. Just if you can raise your hand, I can then enable you and you can talk if you want, or you can just type it into the chat. Okay, there's Christian. I will just allow you to talk. Christian Fonseca, please, the floor is yours. I don't hear you. You are maybe muted. I'm not sure if you wanted to pose the question loudly, but you raise your hand. Okay, is there anyone else who would like to ask in plenary? This is Silvia Crossetto. Okay, you can talk now.
Yeah, can you hear me?
Yes, I can hear you.
Okay. Well, thank you very much for the course. It was very useful and informative. This is maybe a very naive question in a way. So I know that obviously is a European plate observation system. At the same time, I work in the Balkans, and of course, everything is uncovered there. Is there any way somehow that science would ever override this boundary? Because in the end, it's fun in a way to see, you know, the geological map just being interrupted along the political boundaries. And in a way, I don't know, I mean, there is a lot of collaborations with various institutions. So I was wondering if somehow at some point this data could be also implemented, or if it's a matter of, I don't know, the institutions not providing the data. It's just a generic question.
Yeah, thank you, Sylvia, for posing. It's actually a very important question. And of course, EPOS is aware of that. And we are kind of fighting to get the data, as many data as possible to the system. So there was, for example, a project, the EPOS SP, the sustainability phase, in which we were focusing on different areas. One of them was the Balkan area. The second was the Baltic region, because both of those areas we don't have direct, or they are not directly connected to specific communities. So we're trying to engage them. One of the results is that actually now we have Croatia, who just joined the EPOS ERIC as a formal member. So, and we are communicating also with other countries. There was an Adria Array workshop, which is, let's say, the seismology community workshop organized in Montenegro in the autumn last year. So there is slow increase of communication and engaging scientific communities from that area. So we hope it will include more and more assets from these areas. Now we are also working and preparing a new project proposal, again focusing on the new countries or countries which are not members yet, to get them on board and get the data integrated in a proper way. So there are different fronts or different channels through which we are trying to engage with the new countries and the new data providers. There was Sylvia, do you have further questions, or it was just this one?
No, that was all. Thank you very much.
Okay. There was also one question to understand how to get in touch with the specific data provider. So I will just show it. Now I will start sharing my screen again. And I will go back to the EPOS Data Portal. And I will show you, because each service has this small I letter next to the service title. So if you click on that, you get the metadata information. We haven't explained that during the demonstration, but I think it's quite obvious. Under details, you can find the name, the description of the service, the spatial coverage, the temporal coverage, also the quality assurance link. It means describing how the data are treated before entering the service, who is the actual data provider or providers. And at the very bottom, you have the service details. So where is the actual server located, how to use the service through the service documentation, who is the service provider, etc. On the top right corner for each service, you can see this Contact Us button. For that, to be able to do that, you need to log in. I mean, the whole system provides access to data for free and openly, just to be able to track who is making the questions and also avoid robots. You can authenticate. For example, now I'm doing it with my Google account. And once you authenticate it, then you can open that Contact Us field, and then you can specify what is your question about and send the message directly to the data provider or service provider. You will get it and copy to your mailbox. So that's how you get in touch with individual data providers. The way how the data is integrated in EPOS, it's that not anyone can upload the data to the system. It always goes through the community. So you should find the community which is closest and managing the data sets, and then they will instruct you how to prepare the data to be able to share them through the EPOS system. Okay, I will stop sharing again. Is there anyone else who would like to ask? Okay, there are some comments in the questions and answers, but not explicit questions.
I know that this is more for data services, but is it possible at all to, let's say, populate the map and then export the map with the data on it? I was thinking, for instance, for the INSAR data, that it would be nice, since they are already positioned geographically and they are already processed, then just export the map, let's say.
Well, currently we don't have this feature for exporting the map. We have it in the graph view that Harald showed, that you can export the image from the graph view. From the map, currently you can do only the screenshot. That's the only thing you can do. So if you have high resolution screen, you can make a screenshot and it will be quite good quality, even maybe for publication. But of course, if you want to have it, let's say, in really high resolution or vector data, then we don't have that yet. And so for satellite data, you might need to download the actual data and then visualize them. But we are working also, as I mentioned, on new visualization tools, which we want to connect to the central system. So it will provide additional visualization, not only the map, but also other kind of graph views as you would like to show.
So for instance, reasonably, if one would like to use something, let's say, quickly done for a presentation, for example, then in terms of citations, do you think that would be enough to cite the EPOS portal, or given the individual services that are provided, it's better to actually check the source of each data that is included?
Yes, we strongly encourage users to always cite the data providers or the service providers. You can find the information in the details. If you cannot, you can always contact the data provider to make sure that you are using the right reference. We're also working now on citation guidelines to make the proper references better visible. So it's also ongoing work to either guide the user which reference explicitly to use, either if you are using the service or if you are using specific subset, or if you are using the portal as a whole, either for teaching or for demonstrations. So that's we are working on right now.
Okay,
for
you.
The EPOS Data Portal itself, we got published scientific papers in Nature, in the scientific data section of the Nature journal. So you can find the reference there for the portal as a whole.
All right, thank you very much.
Okay, I'm just going through the questions here. Yeah, I see there's a acceleration time series general users. Yes, well, if you go to seismic services, they have access. They provide access to the waveforms, and it depends really on which networks and which stations you are interested in, and then you can find. There's also specific acceleration data related to earthquakes, so you can find them. So if you explore the seismology community assets, I'm sure you will find that. Yeah, earthquake records. Yes, that's basically we are connecting to different data archives to the IDA nodes. If you maybe know, ADA stands for European Integrated Data Archive, which is distributed or federated across different nodes. I believe now we have 12 IDA nodes, basic data servers around Europe, and each is serving its own networks or networks which are connected to this data center. So you can explore that. You can go maybe through first look at the stations, figure out to which data center they belong, and then get the actual waveform data. Yeah, there's a question also about the INSAR data. Why not integrate data from the results from the EGMS? Yes, we were looking at that, and we are communicating with them, but that's really the satellite community itself who need to decide which data and the way how they are processed they want to share. So it's not really EPOS deciding what data we would like to expose. It's rather the individual communities within EPOS who are in charge of approving the data quality, and the methods how the data were processed. But yes, this was already discussed at the EPOS level. I am aware of this service pretty much myself, because that's providing really pan-European coverage. It will be much better to have that one included in addition to those small, highly detailed studied areas. Okay, Liubka pasted the link to the paper. Thank you, Liubka. Yeah, so I think there are no other questions right now. So I believe we can close the training. Thank you very much for your time, for being patient, especially when the system was overloaded. But in general, I hope it worked fine for you. And of course, if you want to get in touch and get, let's say, specifically dedicated training, you can contact Federica Tanlongo, who is here in the meeting, or you can contact myself. I will redirect your request further, and we will get coordinated to understand when to arrange next training in which focus. So thank you for your time and enjoy the portal, and please start using it, teaching or research, exploring the data, because the more usage we have, there's a better chance that the more support we will also gain for the scientific data and basically for you. Thank you and goodbye.